Hello, here's the question number 11. It reads that there is a cylinder of length 10 centimeter and it is made of a material whose density is 0.65 gram per centimeter cube and that floats half submerged in an ideal liquid kept in a vessel which is closed as shown in this figure. Air in the vessel has a density 1.3 kg per meter cube. If the air pressure is made 100 times to the initial value, what you are going to observe? So first thing we need to say whether the cylinder is going to move up, down or not, and then we need to find if it moves how much the displacement it gets. So here's the solution, and this is the picture. So this is liquid, ideal liquid, this is cylinder, and this is closed. Now for air, we can use P is equal to rho RT upon M, assuming it to be ideal gas. So we will say that if pressure is increased, R and M remain same, temperature is considered to be constant, so density has to go up by 100 times. So increase in pressure of the air will cause increase in the density of the air, and we know at equilibrium this cylinder is going to experience a buoyancy from the liquid and buoyancy from the air that will be balancing the gravity. Now since liquid is ideal, so it's not going to have its change in its density, whereas this upside fluid is having more density now, so this will cause the buoyancy to increase. So buoyancy of air will increase, hence the net force will come in the vertical direction, vertically up, hence the cylinder will move in the upward direction. So that's what it says, which in turn increases the force of buoyancy on the cylinder due to the air, and this is causing the cylinder to go up. So we will say the cylinder moves upward direction. Now we need to find out by what amount it moves in upward direction. So initially we can have a force balance, the forces that I just explained. Buoyancy of air, buoyancy of liquid is equal to the weight. Buoyancy of air is going to be, let's say, X amount, X is the length in the air, and it's given half submerged, so X will be equal to basically L by 2. So let's say area is the cross section area is A. So area into the length, that is the volume submerged in air, into density of air, into gravity, that's the buoyancy of air. Similarly, area into the length in the liquid is, and the density of liquid with the gravity is the buoyancy because of liquid. And for weight, we can write the mass into gravity, mass is volume into density, volume is going to be A into the length, and density of the Cc for cylinder. Now we can substitute X is equal to L by 2 because it is given initially it is half submerged, and then you'll find A and G will get cancelled out from both the sides, from all the terms. And I'm substituting X as L by 2, so it's going to be L by 2 rho air for the first term. Second will become L by 2 rho L, and last term or right hand side term is going to be L into rho C. Again L is getting cancelled out, and from here rho L, liquid density, because liquid was not known to us, so its density can be calculated from here. It's going to be 2 times the density of cylinder minus density of air. Now we put the value, density of cylinder is 0.65 gram per cc. So if we convert into SI units, so it's 650 kilogram per meter cube into 2, and air density is very small, which is 1.3, so practically it's going to be equal to 2 times density of cylinder, and it's going to be basically 1300 kg per meter cube. Calculation you can check. What happens finally? Let's finally the length of the cylinder in the air portion is x dash. So we will write the same equation replacing x by x dash. So it's going to be x dash over here, x dash over here. That's a new length, and rest will remain the same. So again we are using buoyancy of air, buoyancy of liquid is equal to weight, but buoyancy of air has changed. So buoyancy of liquid has to be changed, so both these two have changed to maintain the same weight, and these are changes are here. Now when we simplify this, we can say x dash will be having in common that's rho density of air and density of liquid with a minus, and another term will be going this side, so that will come with L, so density of container or cylinder minus density of liquid. So from here we are getting x dash as this expression. Now L is known to us, we can put later on, but densities we can put here. So density of liquid is 1300, density of cylinder is 650, and density of liquid we have just used. Density of air, now it has been increased by 100 times, so when we increase 100 times it becomes 130. So this becomes 130. Now you can divide upside downside by 130. So that will become 10, that will become 5, this will become 10 and 1. So basically it comes out to be 5L by 9. Now L is known to us, right? So we can say how much this is in numbers. Since we need to find the displacement of the cylinder, so we will say the final length is x dash, initial was x, so the change is basically x dash minus x, and that's the displacement, which is 5L by 9 minus L by 2. Simplify to L by 18. L is 10, so 10 divided by 18 centimeter, which turns out to be 0.555 centimeter, or we can write it as 0.56 centimeter. So out of C and D options, C matches perfectly. So we will say our final answers are A and C, and that's how it's completed. Thank you.